Hi friends, welcome to Answal. So today it is the 75th episode in the space series. So today we're going to discuss about neutron stars. So in the last episode of the space series, we discussed about black holes. Yes, they're pretty similar to neutron stars in the way they are formed from very massive stars going supernova. Yeah, so which is a pretty powerful explosion. So we have a star. Yes, there's the nucleus. So in the nucleus is where the nuclear fusion happens, like where the hydrogen turns into the helium. Yes, and helium turns into carbon and until iron. So iron can't fuse again with its iron. So wait one second. So iron, it is pretty dense, so it can't fuse with other iron to form heavier elements. So the core gets stuck like this. So because of all of this nuclear energy, the nuclear force, a lot of radiation is made. So because of this, so the gravity of the stars doesn't push into the core. Yes, because the radiation is opposing the gravity. Simple. Okay, but when there's no nuclear energy happening, the gravity just pushes in, creating a supernova. Most of the particles are just spewed out. Most of the outer area, like the sun part mainly. Yeah, but the core still exists. A lot of iron still exists, but it gets like, so for example, this is the earth, and wait, let's take another color, another marker. Okay, this is the earth. So now the sun's core is like approximately the size of earth. So our sun is not predicted to turn into like a neutron star or any black holes, but let's just think the sun is going to turn into a neutron star. Okay, so the core of the sun before it went supernova is just pretty much the size of earth. But because of the supernova, after supernova happens, it will literally turn like a very small dot. But it still has a lot of density. It's very dense. So this thing could be literally 25 kilometers, but still more dense than the earth, like 1,000,000 times more dense than the earth. Yeah, they're too powerful. So let's take an example. So there's Mount Everest on earth, right? Okay, so the weight of Mount Everest can literally fit in let me literally rephrase it. Okay, so let's take a small 1 centimeter cube or chunk of this small thing, of the neutron star. Okay, next let's take Mount Everest. Both of these have the literal same mass, Mount Everest and the small piece of the neutron star. We can literally hold it here, but we'll be literally sucked into it and it will be too massive. Yeah, okay. So next, the structure of a neutron star. What is inside of it? So first, before all of this, let's just discuss the why they are known as neutron stars. Okay, so let's take a normal atom. Let's take helium atoms. So there are protons and neutrons. So protons have a positive charge. Meanwhile, neutrons, no charge. And for helium, there are two electrons which have negative charges. Okay, so because of the density when the supernova is happening, these electrons will fuse into the protons, creating a neutron, a thing without any charge. So negatives plus the same equivalent of it in positive is equal to 0, nothing, which is literally a neutron. Yes, so because of this, so most of the particles, the atoms of inside these neutron stars are mostly just neutrons. That's why they are known as neutrons. Okay, so then let's go to the structure after we just explained what happened. This took a lot of place. Okay, so next it has 3 main parts. So this is a neutron star. Let's just cut it open because why not? Yeah, we have pretty big blade. So its structure is pretty much just like planet, even though it has a name of a star. So it has 3 main parts. First, an atmosphere. Yes, an atmosphere just like Earth. Not just like Earth, but it is pretty hot. Don't touch it, please. Your hand will burn. You'll turn into spaghetti. Next, there's a crust. where you can stand on, but your your legs will melt. And last and finally, a core, just like every other planet on in the universe. Yes, okay. So first, let's just zoom into this small place. Zoom in and zoom in very small until we go into the atomic scale. Okay. So there are like many layers of this. So because of the density, the iron atoms, which are mostly just neutrons, will just turn into a crystalline state, a very crystalline state. And the deeper you go, the more density is. On the top, it is like, yeah, they're pretty good. They're just separate atoms. But then in the bit bottom, they'll be closer. Just a bit closer. This is known as the spaghetti layer. Yes. And last and finally, they'll be like right next to each other. Too dense. So this inner part is known as neutron pasta. Yeah, pasta. The strongest thing which we know of. More stronger than diamond. Literally indestructible. If we take some of this and take a few centimeters of it, it will be more dense than Mount Everest. I just told before, right? Okay. Until we reach the core. So this is just for the crust, main crust part. But in the core, we still don't know what it is comprised of. If it is just atoms or a quark-gluon plasma. So quark-gluon plasma is so for simple. It is all of the atoms. They'll just completely separate into neutrons and protons, which will again separate into quarks and gluons. And this plasma is made up of those quarks and gluons only. Okay, so this is the structure of these stars. We'll just rub it. Okay, we learned about them, right? So what happens if two neutron stars hit each other? What happens then? That's a very good ground. So two neutron stars, perfectly good. They just come into each other and they hit each other. Okay, so an explosion happens. An explosion more powerful than any other supernova ever. This explosion is known as a kilonova. Yes, so very dense materials are caused because of this. So this is so powerful that the atoms inside the neutron stars can literally uncrystallize and crystallize back together. Yes, great. And after these explosions, they can turn into a very powerful neutron star or the one and only, the mysterious black holes. Okay, yeah. So there's also one theory told by scientists that so we have many big elements, right? Very heavy elements like gold or iridium. Yes. So people think that they were not there since the start of the universe. They were just like hydrogen, helium in the start. And then after stars there was like iron. But after that, how could they get more more elements? Yeah, as the inside neutron stars is only neutrons. So what happens is the theory is that when these explosions happen, the kilonovas, the new heavier elements are created. Yes, and they're literally thrown out into space where they'll create new stars. That's a cycle which never ends. Okay, so next, last and finally, we're going to discuss about the types of neutron stars. There are three main types of neutron stars: magnetars, pulsars, and magnetars plus pulsars, both of them at once. Okay, so first, magnetars. So just after these neutron stars are born, just fresh out of the oven, just big, ready to be eaten by us. Yes, so they'll just spin like this. They're like a ballerina, just spinning everywhere at high speeds. Yes, so they also have magnetic field and electromagnetic field, which is very powerful. So these magnetars have these electromagnetic fields. Okay, so they are so powerful that they form a magnetar. Yes, so this is for the magnetars only. Next are the pulsars, just like the magnetars, but okay. So the magnetic fields again, we take these magnetic fields. So the solar radiation or any other radiation coming from space will just go up here, just like in the aurora borealis. And then the neutron star will create jets. This is known as a pulsar, and these pulsars also go in very fast speeds, breaking these rules. Yes. And then a pulsar plus magnetar. You can understand it by its name. It's just both of them at once. A neutron star doing both of them at the same time. Pretty great. Yes, the neutron stars are pretty powerful, we understood. See you for today about neutron stars. Bye.